Now we need to begin simulating. So the first thing we're going to do here is pack our geometry. Okay, so if I zoom in closely here and put on the point display, you can see we've got lots and lots of points. The geometry spreadsheet. If we go to our points, we can see we got 942,000 points. Now, if I drop an assemble node, highlight that, and then check this box, create packed geometry, we'll see a change. Okay, the points on the surface disappear, but if I put on the wireframe visualization, you can see in the middle, hopefully you can see them there, there are, for each object, individual object, there is 1 point. And we can confirm that if we go to the geometry spreadsheet again. Yeah, we can see from 0, so we got 500 points and 500 objects. And what's also new is we have this new attribute called name. So each object has a name, okay, and each name is different. They're all unique. And the reason we're doing this is we're going to be using Bullet to simulate, and Bullet requires packed geometry. You can simulate without the name attribute. In this case, we're not using constraints, but when you use constraints, it's important to use the name attribute. So I tend to just do it by habit, give a name attribute, and I like to give it something unique. So I'll give it this name, coffee bean. Okay, so each one has a different name, coffee bean 0, 1, 2, 3, and so forth. Okay. So next, let's dive into a DOP network. So tab DOP, DOP network there. So at the moment, we're inside this SOP network where we work on surface operators. Okay, we go inside there. That's what we've done so far. Now we've built another network where we can, which is a DOP network, and you can see the name here, dynamics. So DOP stands for dynamic operators, so where we build simulations. So here we got the output. We're going to connect everything into that. So we need to again pull in geometry. We need to find the geometry and import it. So to do that, we need a RBD packed object. Okay, so again, this term packed, which refers to this type of geometry, which is more efficient. And instead of pointing to the path, what you can do is just use this first context geometry. If we put visualizer there, we have our geometry in DOPs. Next, at the moment, it's not doing anything. We've just pulled in the geometry, but nothing's happening to it. There are no forces applied, nothing to simulate. So let's add a rigid body solver and connect into the first input. It tells you objects into the object, and the solver to the output, and visualize that. So if we press play now, take a moment just to import the information. and it will start simulating. Okay, so this is simulating, but nothing's happening. There are no forces acting on it. So let's go back to the start and give it some force. So we could give it some gravity, for example. Let's take a look at that. Again, importing the data, and there you can see it's going down. Those yellow lines you can see are visualizations of the point trails, the velocity. Okay, so you can, if you don't have that on, oh no, it's here. Sorry, I created this visualizer for the velocity. You can turn that off if you have one as well. Okay, so they're a very simple but boring simulation. What we could do, just to make it a bit more interesting, is create a ground plane, sorry, merge. And typically in SOPs, the order of these don't matter, but in DOPs it does matter. Basically, just keep the ground plane on the left. You can either do that, so swap them here, or set this to set this to mutual. Otherwise the objects will just pass straight through. And I'll just drop this down very quickly. We're not going to keep the ground plane in our simulation. It's just to show you that, you know, we've got something going on. There we are. Moving down, you can see them colliding with the ground. Perfect. So I won't let that play through, we don't need to see it. An important concept with bullets is the collision geometry. So what you see here is the geometry that we have imported into the DOP simulation. However, it's not technically what's being simulated. To see that, if we go to our packed object, go to bullet data, and then click on show guide geometry, and there we go. You can see what's actually being simulated here, these blue collision holes. And I can actually hide the geometry there to see more accurately what's going on. There we go. So you can see they're not exactly the same as our geometry, but they're an approximation which is well, for one thing, it's necessary for bullets, and it's also quicker to simulate, to do the math on this. So you have different options. In this case, we've got a convex hull. Okay, so there are no parts which are concave. It's recommended not to use the concave. It's very unstable and very slow. So I never use this, to be honest. Box, you can use a box. To be honest, we could probably get away with using boxes here. It would be a lot faster. It's not updating for some reason. Let's see, maybe I need to go back to the first frame. Yeah, there we go. So this will create a box, almost like a bounding box around the outside of the object. Capsule, cylinder, compound. Doesn't work in this case. a sphere, which is probably the fastest, or a plane. We'll stick with a convex hull, just default. But if you can, I recommend using either spheres or boxes. If you're struggling with simulation time, it's a good thing to it can help you with your simulation times. Okay, I'm going to turn off that visualization because it runs a lot slower when you're visualizing the collision hull. And delete the ground plane. Okay.